Good day. Today we're going to be looking at applications of quadratics. I'm going to start at number 3. The dimensions of a rectangle can be expressed by x plus 6 and x minus 2. I'm going to start by drawing this diagram. If the area is 65 square inches, find the dimensions. You need to know the formula for the area of a rectangle. Length times width is equal to the area. X plus 6, x minus 2 equals 65. Whenever I FOIL this, I'm going to get x squared plus 6x minus 2x minus 12. I'm going to combine like terms and move the 65 over via subtraction. X squared minus positive 4x minus 77. My factors of 77, 1 and 77, 7 and 11. I want the bigger one to be positive. And because of this minus, they are opposite signs. And this does come out to be positive 4. So I have x minus 7, x plus 11 equals 0. What minus 7 is 0? That would be 7. What plus 11 is 0? That would be negative 11. Okay, negative 11 does not work in this problem. I cannot have negative length. We're not finished though. This said, find the dimensions. What I have found is x. So I'm going to plug this in. You can label length or width if you want. I'm just saying dimensions. Seven plus 6 and 7 minus 2. 13 and 5 are my dimensions. Okay. You can try number 1 and 2 if you want. I'm going to be looking at number 4. The base of a triangle is 7 less than twice the height. If the area is 102 centimeters, find the length of the base. I have a triangle. I don't know it's a right triangle, so I'm not putting the right angle marker. But I do know the formula for area is 1/2 base times height. I know my base is 7 less than twice the height. And it doesn't tell me anything about the height, so I'm going to label it x. The base is 7 less than twice, 2x minus 7. And the area is 102. Plug in my base and height. 1/2 times 2x minus 7 times x equals 102. From here, I'm going to type this into Desmos. 1/2 times 2x minus 7 times x, instead of equal, minus parenthesis, 102. I have x is equal to negative 8.5 and x is equal to 12. I do not use the negative distance, so I'm going to go 12. Now the problem says find the length of the base. So my base is 2 times 12 minus 7. This is 24 minus 7, 17 centimeters. Five and 6, I'm going to set up, but I'm not going to solve it. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. Time out there. I have a hypotenuse. I have a right triangle. In the back of my mind, I'm going to be thinking Pythagorean theorem. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. So I have the short leg, I have the long leg, I have the hypotenuse. The long leg and the hypotenuse are based off the short leg, so I'm going to call it x. The longer leg is 7 feet longer than the short leg, so x plus 7. And the hypotenuse is 1 foot more than twice the short leg. 2 times x plus 1. This is all the information it gives me. Because this is a right triangle given the hypotenuse, I need to use Pythagorean theorem in order to solve for x. Now I'm going to let you do that. I'm going to give you the clue, maybe. Short leg squared plus long leg squared equals hypotenuse squared. That is a theorem that you need to be using. Okay, try that. For this one, I'm going to let you set it up. I just want to point out for a rectangular prism, volume is equal to length times width times height. You should know that formula, but if not, there it is. Number 7. We have a rectangular shaped vegetable garden that is 15 by 9 feet. He wants to increase both length and width by the same amount. We don't know the amount, we're going to call it x. Such that the new garden is twice the current area. Find the value of x to the nearest tenth of a foot. Well, I need to know what the area is of this first rectangle. So 15 times 9. This is 135 feet squared. So I want a grand total of 270 square feet of garden. Okay. To get this, I'm going to be multiplying 9 plus x times 15 plus x equals 270 feet squared. Okay, at this point you have two options. If we work this out, FOIL this, I'm going to get 135 plus 24x plus x squared, 270. I'm going to rewrite this in standard form, so x squared plus 24x minus 135 equals 0. Okay, I have that. There is no combination of factors that I can pull out of this. So I have two options. I can use the quadratic formula. The x is equal to negative b plus minus square root b squared minus 4ac all over 2a. I can use that. A is 1, b is 24, c is negative 135. Or I can use Desmos. Now the choice is ultimately yours, but I'm feeling lazy today. Let's use Desmos. X squared plus 24x minus 135. 4.7. That's that nearest tenth of a foot, right? Yep. Done. Given the diagram below, if the area of the shaded region is 59 inches squared, what are the dimensions of the outside rectangle? Now I'm going to set this one up for you, and we're going to talk about it. So this shaded area is 59. I am excluding this whole. So in order to get 59, I would take x plus 6 times 2x minus 1 to get the entire area all the way through. But then I'm going to take out that white rectangle of x times x plus 3. And when I take out the white rectangle, there we go, I will have 59 square inches. There's the formula to solve. And then plug it back into the outside rectangle to get the dimensions. Numbers 9 and 10. I'm going to do, I think I'm going to do numbers 9 and let you do number 10. Find two consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger is 24. All right, so I have two integers. I'm going to call this one my first and second. These integers are odd. I don't know what the integer is, so I'm going to label x. Now let's make up an odd number. 13 is my favorite number. Let's use 13. If 13 is my first number, the next consecutive odd integer will be 15. To get from 13 to 50, I need to increase by 2. So this will be x plus 2. Okay. I don't know what these integers are. I can find those here in a minute, but this will be my representation for them. The square of the smaller added to 3 times the larger is 24. The square of the smaller integer, my smaller integer is x squared. I'm going to write that in words, well, words in quotations first. First integer added to 3 times the larger integer. Okay, that's what I'm doing. Plug in my first and third, so x squared plus 3 x plus 2 equals 24. This one is easier to do by factoring. X squared plus 3x, maybe not easier, but it is faster, plus 6 equals 24. Subtract 24 from both sides. Okay, factoring this, x plus 6, x minus 3. Therefore, x is equal to negative 6 and positive 3. I don't care about the negative, so I'm looking at 3. My first integer is 3. My second integer is 3 plus 2, 5. Finished. Try number 10. This is all that I have for you today, so let's look at the answers. This is it for Unit 2. I hope you have a great rest of your day.